Alright everybody, welcome back to what should be the final video, the fifth and final video on integration using substitution, section 6.9 of AP Calculus. We're going to work our way through a few more examples here, pick up where we left off, and we'll start here with example 4. We're integrating the cosine of the square root of x over the square root of x. By all indications, if we're doing this by substitution, it seems like the obvious substitution is u equals the square root of x. Okay, but do not just assume that we are going to replace both of those square roots of x's with u. This is something that comes up very often when we're making a substitution where our substitution is the square root of x. When we take the derivative of this, remember this is x to the 1/2. So when we take the derivative of this, it's 1/2 x to the negative 1/2, which is equal to dx over 2 square root of x. We move the x to the negative 1/2 down into the denominator, change it over to a square root. And so when we make the substitution with u equals the square root of x, we need a square root of x as part of the du. We need that square root of x in the denominator as part of our du. So in reality, I'm going to multiply both sides by 2 here, and instead of replacing this square root of x, that's going to be part of our 2 du. And so with this substitution, this turns into 2 integral of cosine of u du. And now I can go ahead and integrate. This is going to be 2 sine of u plus c, and then we bring u back, and there's our answer. All right, here we go. Example 5. Integrate 2x cubed times the square root of x squared plus 1 dx. Again, our first instinct is to make our substitution something that is inside of another function in some way. And so my first bet for substitution here would be u equals x squared plus 1. Okay, if I make that substitution, then du is equal to 2x dx. And what happens here when I try and put all this stuff back in here, I can't even highlight properly here. I'm going to replace that with a u, and I'm going to replace 2x dx from here with a du. But this is very similar to example 1. I have an x squared left behind when I replace this with u and this with du. And so in order to finish this problem, I need to solve and figure out what x squared is in terms of u. I go back to my original substitution, and I'm going to solve this for x squared. So x squared is equal to the quantity u minus 1. And so I'm just going to go ahead and replace this with the quantity u minus 1. And then I can distribute the square root of u through the parentheses, so this becomes u to the 3/2 minus u to the 1/2 du, and then I can go ahead and take the antiderivatives. This is going to be 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus c, and we'll bring u back, and this turns into 2/5 times the quantity x squared plus 1 to the 5/2, minus 2/3 quantity x squared plus 1 to the 3/2 plus c. Boom. There is our integral in example 5. And then in example 6, we're going to integrate. We've got the integral of the arcsine of x over the square root of 1 minus x squared dx. Pretty common substitution that we've been using, or some of the more common substitutions we've been using, is substituting part or all of the denominator as u. That's not going to work in this case because of that arc sign that we have up there in the numerator. Obviously, if we take the derivative of some expression like the square root of 1 minus x squared or just 1 minus x squared, there's no way for us to get an arc sign in there. But if we remember our derivative rules, we should know that the derivative of the arc sign of x is in fact 1 over the square root of 1 minus x squared. And so that makes for the perfect substitution in this problem. U is equal to arc sine of x, and du is equal to 1 over the square root of 1 minus x squared dx. And so this is exactly my u, and this is exactly my du. And so this turns into the integral of u du. I integrate, that's going to be u squared over 2 plus a constant, and then I bring u back, and so that's arc sine of x squared over 2 plus c, and know that -1 is not an exponent, so you cannot apply the 2 to that and make it the sine to the -2 of x. Please, please, please remember that when we have that -1 with our trig function like that, it's representing the arc sine and not 1 over the sine. All right, that brings us to the end of this section, section 6.9. We're done with it. End of this video as well. Join us next time. We're talking about section 6.10, which is going to be integrating with the help of long division and completing the square to simplify our integrands. All right, see you then. Enjoy the rest of your day, and I'll see you the next time I see you. Bye-bye.